Good afternoon and welcome to today's webinar, Understanding MRI Equipment Quality Control. My name is Kelly Baer and I am Creative Design Manager with Marketing Communications at IAC. Before we begin, I'd like to take a moment to review a few technical matters and let you know how you can participate in today's session. We would like today's webinar to be interactive, so we encourage you to submit questions. To do so, use the Questions tab located on the left side of your screen. Please submit your questions anytime during the webinar, as we will be monitoring questions throughout the presentation and will try to answer as many of them as possible during the Q&A period. Also on the left side of your screen is the Resources tab. Click on this tab for links used in today's presentation, as well as a PDF copy of these PowerPoint slides. Select the file name to download the PDF. Lastly, in the lower left of the player, please note the Request Support button. If you experience any technical problems during the course of this webinar, you may click this button. A technical expert will be there to assist you with any issues you may have. For those who like to take notes during the presentation, look to the right of the slides and click the Notes tab. There you will see a white text box where you can take notes on today's webinar. These notes will be emailed to you automatically at the end of the session. To be eligible for the ASRT CE credit, you must be registered, logged into this webinar, then complete the survey. The survey will open automatically at the conclusion of the live session and be available from the IAC Pro Library's website for 3 business days. If you are viewing this webinar in a group, please be sure you are also individually registered and logged into this webinar on another computer or device so that we have record of your attendance today. Today's presentation is being recorded and will be posted at a later time for on-demand viewing. And now I would like to introduce today's guest presenter, Dr. David Jordan. Dr. Jordan is the Senior Medical Physicist at the University Hospital's Cleveland Medical Center and Associate Professor of Radiology at the Case Western Reserve University in Cleveland, Ohio. He is certified by the American Board of Radiology, the American Board of Medical Physics, and the American Board of Science and Nuclear Medicine, and the American Board of Magnetic Resonance Safety. Dr. Jordan serves on the IAC MRI Board of Directors representing AAPM. He has co-authored numerous articles and book chapters and has lectured nationwide, and we are happy to have him with us today. And with that said, I will now turn this webinar over to today's speaker, Dr. David Jordan. Doctor?
Thank you, Kelly. Good afternoon, everyone, or good morning, depending on where in the country you're joining us. So this afternoon, we're going to be going over the MRI equipment quality control requirements that you will find in the IAC's MRI accreditation program standards. We'll be talking about documentation of that MRI equipment quality control and different ways to go about that, different things you want to look for. And then we're going to spend a little bit of time reviewing some of the specialized terms or trade names that you'll find in documentation that you would receive from your MRI equipment manufacturer, from your field service engineer, to try to line up those specific tests or specific items that are done, particularly during a preventative maintenance visit, with those general terms that we use in the IAC standards to understand how those activities apply to your accreditation requirements. So for our first section, we're going to talk about the contents of the IAC's MRI accreditation standards, specifically as they relate to equipment quality control. If you review the standards, which are available through the website that's posted on this slide, you will find a section that describes types of QC and then the frequency of those QC, or the incidents where those QC tests are required. So there's a detailed list of frequencies. We'll go through those here in detail. So the QC that's described in the standards breaks down into 3 major categories. You have acceptance testing, which is required for installation of a new MRI unit or for a major upgrade of an MRI unit. There are periodic or routine QC tests, which would be done daily, as well as potentially other frequencies such as weekly, monthly, quarterly, sometimes semi-annually. And then there are preventative maintenance. So acceptance testing is done according to the standards by the manufacturer's representative or a service engineer, or this can be done by a medical physicist. This would include a number of tests, which are more in-depth and more lengthy than what you would see for routine QC. So the tests that are listed in the standards are magnetic field homogeneity, gradient and RF calibration, resonance frequency, slice thickness accuracy, slice position accuracy or slice accuracy, signal to noise ratio for all of the coils on the system, spatial resolution, artifact assessment, image uniformity, image linearity or geometric distortion, and monitor and processor QC. Routine QC is required on a daily basis by the technical staff at the MRI facility. This must include the proper function of devices that are used for patient safety. Typically, this is going to refer to devices that are used to maintain the equipment operator's ability to see and hear the patient throughout the MRI study, as well as checking and monitoring the MRI unit's center frequency, signal-to-noise ratio, image uniformity, and an artifact assessment. In addition, sites are required to perform any other tests that are recommended or required by their MRI manufacturer, and this will vary based on different MRI manufacturers, different models. Different manufacturers will have different test intervals, so they may require certain tests to be done on a weekly basis, monthly basis, etc. Sometimes they're spaced out as infrequently as quarterly or semi-annually. And again, this is going to refer to testing that's designed to be done by an MRI technologist, by an on-site MRI equipment operator. So this is not referring to testing that's done periodically by a third party, such as a service engineer or a physicist. So these items under routine testing are going to be considered the responsibility of the MRI facility's technical staff. Preventative maintenance is another category which sort of spans over into quality control. So preventative maintenance is typically going to involve a series of repairs or adjustments to the system that are done on a routine basis to try to keep the system operating at its best, performing correctly. As part of the preventative maintenance process, we expect that the service personnel are going to conduct a number of tests on the system to verify the system's performance. Within the IAC MRI accreditation program, the requirement is that the preventative maintenance has to be done according to a schedule or an interval that's described by the manufacturer in their MRI system documents. But it has to be done at least once a year. So if your MRI manufacturer does not specify a frequency of preventative maintenance that's annually or more frequent, you're still required to do this maintenance once per year. And this preventative maintenance, when it's done, must include a number of specific QC tests or measurements that have to be documented in the preventative maintenance service report. The IAC standards list a number of tests or assessments that are supposed to be performed as part of this preventative maintenance documentation. These are expected to be done by either the manufacturer's service engineer or there's a provision for other trained personnel to perform these assessments. So that may be a service engineer from another company other than the company that originally manufactured the MRI system. This could be a member of the clinical engineering staff at the hospital or the facility where the MRI unit is in service. So there's a provision here to allow other personnel who have had training to perform maintenance on the system to provide these assessments. So these would include many of the things that are listed as part of the acceptance test for a new system. So signal-to-noise ratio, magnetic field homogeneity, RF calibration for all the coils on the system, spatial resolution, artifact assessment. So in reviewing accreditation submissions for facilities applying for MRI accreditation or MRI accreditation renewal, a large amount of the documentation that's being submitted is documentation of these QC tests to show that they're being done on the proper frequency, to show that they are meeting the standards that are set forth by the MRI manufacturer in terms of the performance of the system, ultimately with the goal of ensuring that the system is ready to do the best work possible to produce quality patient images. So this is my one little special joke slide. So we hear this all the time in the world of medical imaging, in the hospital environment, in dealing with our regulatory environment. You can do a fantastic job with testing, with maintenance, with all of these things. And if your documentation falls short and it doesn't demonstrate that you actually did this testing to the standard that's set forward, whether it's the IAC standard or whether it's a regulatory standard, you name it, you're going to have a problem down the line if you can't demonstrate that you did everything in the manner that you're required to do or in the manner that you claim that you did. So this is one of those areas where there's a lot of room for improvement, even in processes that are being carried out correctly and in a timely fashion, but where we find that when we sit down to look at the documentation, it just doesn't bear out all of the details to show that that work complied with the standards, even if in fact it did. So if you go back to the IAC MRI accreditation standards, which I had linked on one of the early slides, and I think these are available off to the side of your player in the resources window as well. All of the items that are listed as QC or preventative maintenance requirements must be documented by the MRI facility. And the documentation has to show the name of each test that you're doing, the name of each parameter that you're testing. Now, I'm going to talk a little bit about the differences in terminology between perhaps what the IAC standards refer to versus how an MRI manufacturer might refer to some of these tests. And that's important because if you're using a preventative maintenance report from your MRI manufacturer service engineer, or if you're using a form that you've copied from the manual for your MRI system, it's important sometimes to be able to crosswalk those terms and say, okay, what we did is called X, and this actually fulfills something called Y under the IAC standards. And whether you can reflect that in your documentation or whether you're able to explain that, ultimately that's something that it's important for you to be familiar with in your MRI facility in order to be able to discuss that with the IAC program staff. Your documentation has to show the value or the result that you measured. And this is important, particularly for tests or measurements that result in a number. I'm a stickler for this because I also do mammography, and in my state, my mammography inspectors are sticklers for this. But they say if the test says you must measure something, and it has to be between 4 and 6, and you measure 5, you have to write both 5 and pass. You can't just write pass. So this is important because of the next item. Your documentation also has to show what's the range for that value. So in my example, my documentation would have to say, well, I measured 5, and anything from 4 to 6 is acceptable, right? So we want to be able to see in that documentation, what's the reference level? What's the expected level? What's the passing range for that result value, right? Only after we've shown the value that we measured as well as the expected range is it then appropriate to say pass, fail, check, no check, etc. Our documentation for accountability purposes also needs to show the name of the person who did the testing or who took the measurement and the date that it was performed. In addition to those requirements that cover all quality control, when you're looking at items that are done as part of acceptance testing or that are done as part of preventative maintenance, these additional requirements include the signature of the person doing the testing. So the report has to be signed. So you don't have to sign every day for your daily QC. But for an acceptance testing or a PM report, we want to see the signature of that person in addition to their name. Your facility is required to maintain a complete history. So all of the acceptance tests that have been done, all of the PMs that have been done, you want to have a full history of those on each system that's in service. And ideally, you need to maintain those images or the data from your acceptance tests. So all the scans that are done, phantom images, system measurements, system calibrations, reference data sets. It may not always be preferable to keep all that stuff on the scanner, but if there's a way to archive all of that in a way that it's accessible in case you want to do a comparison, because in the future, when you repeat these tests during preventative maintenance especially, it's helpful to be able to go back and compare and say, well, what was the scanner doing when it was brand new, right? We notice something that looks a little strange. A lot of time can pass between these tests being done, anywhere from 3 months to a year at a stretch, going from one instance to the next instance. So it's very helpful to be able to look at the complete history and say, well, this feature that we're seeing in this particular set of test data, we can look back and say, that was present back at the very beginning when we first installed the scanner, or that has been present for the last 3 or 4 times that we did this. So if nothing else has changed, maybe that's not something we're going to worry about too much right now. I alluded to this earlier. You want to be very cautious when you pull a worksheet from your MRI system manual, or you take a report from a PM visit from your field service engineer and say, okay, I'm required to have a PM done. Here's my PM report. I'm good. You want to go through that report, keeping the information from this webinar and from the IAC standards in front of you, and take a look and see that that documentation really meets all of those criteria. So you may look through a preventative maintenance report from a field service engineer, and it may only list something like a third of the items that are listed on the IAC's preventative maintenance list. Now, why does that happen? Well, one possibility is the manufacturer may say, well, over the course of a year, we are going to assess these 12 different parameters, but we service the scanner quarterly. So during each quarterly PM, we're going to cover 4 of those items. So you have 1 through 4 the first quarter, 5 through 8 the second quarter, and so on. So if you're looking at a single quarterly report, you will not have a complete listing of all the tests and all the results that are required under the IAC's list of required preventative maintenance items. However, if you have done each of those items over the course of the year and you have documentation of all of them, then you do meet those requirements. So that's another reason why you want to have a complete history of all of your PMs, not just the most recent, so that you can look back and say, yes, over the course of a year, right, within that annual time window that IAC requires, we have actually had all these items done. They just weren't all done at the same time. And that's okay. In fact, that's what we expect to see based on the way that most manufacturers set up their preventative maintenance cycles for modern MRI systems. A big problem with a lot of these report forms is that they don't have spaces to list out the numbers and the ranges. And quite often this is not because the numbers don't exist. It's because there are things that are documented internally by the service engineer within the company's software and documentations and logs, and then there's a customer report which is provided to the MRI facility, which doesn't contain all of that same level of detail. So this is something that we're going to come back to here in a few minutes, but I want to point this out too. You may look at those forms, and this may also apply to worksheets that you copy out of a manual to use for your daily QC. It may have space, a line for each day, a place to write the date. It may have columns to put in different test results, but it may just have a box to write pass or fail. And you may say, well, we can record a number instead of just pass or fail, but it doesn't have a place to actually list the range alongside of that or above or below. So you may have to get creative and either modify some of those forms for your own daily QC or design your own. And again, sometimes you'll see these reports where there's some kind of detailed data that's in the background, but what you receive is something that just says okay or pass or a check mark, and you're not able to look and say, well, what's the valid range? What's the number from this measurement? And it may be difficult to get that depending on how the company that's doing the service is documenting that information. If you will visit the link that's shown at the top of this slide, you will find that the IAC has provided an expertly designed and beautifully laid out preventative maintenance report sample. And if I sound biased, it's because I was involved in the design of this thing. So my unbiased opinion is that it's fantastic. So what you will find if you look at this report is something that lists out a great deal of information, some of which may be included, some of which may not be included when you receive a vendor-issued preventative maintenance report. This report has spaces for all of the elements that I've been describing. So whether or not all this information is collected in one place, this is a template for a way to do that. This would be a useful tool to put this side by side with the reports that you receive from your field service engineer and sort of look down and say, okay, are all the things that are on this form also included in this other document that I have? And they don't have to be laid out this way. This is just a suggestion to say, more of a checklist. To say, are all of the things that should be in my preventative maintenance QC report included? And can I find them? And again, depending on the way that your MRI manufacturer performs their preventative maintenance, you may have to collect between 6 months and a year's worth of separate preventative maintenance reports and treat those as a group. So you say, well, all of the preventative maintenance that's done over the course of a year counts within that preventative maintenance interval from the IAC standards. So if you take this form and you say you have 4 quarterly PM reports and you go through and you say, okay, first quarter, I found a spatial resolution check. And second quarter, I found a field homogeneity check, right? So you know that these things are all included and you say, yes, I see the value, I see the reference ranges, here's some comments from the engineer. And it's up to you whether you simply use this thing as a guide or whether you staple a page like this to the front of the stack and fill it out yourself and say, well, the attached supporting documentation, here's the summary, right? I know everybody has time to sit down and recopy information from paperwork you already have. This is really a tool to make your life easier, especially when you're collecting your documentation for an accreditation submission or a renewal, to be able to say, okay, I know that I've got everything that the IAC is going to be looking for when I submit this package. One thing that will probably not work is you will probably not be able to print that form and give it to your service engineer and ask them to fill it out when they do your next PM. So every company that does MRI service has their own computerized system. Many of them are tied into their own standards. So just as your facility is accredited as a clinical provider of MRI services, the companies that supply the equipment and service it, in addition to having to be FDA approved, they also have various other certifications like ISO and things like that. So they maintain very extensive systems, very extensive software. There's a lot of infrastructure there. So their engineers already have a system and a workflow within which they have to work. If you give them a form like this and say, I need you to fill this out instead of printing me the standard report from your company, that's probably not going to be viable for them, and they will probably politely decline to fulfill that request. You will also probably not be able to negotiate this into your service contract in the future, although I wouldn't discourage you from trying. Anything's fair game when you're negotiating a contract. So what I'm recommending with this tool is that you use it as your own guide or your own checklist. And as you receive those reports and as you file them, go through and make sure that all of the items that you need to have covered are actually identified somewhere in those factory reports or those service company reports. Specifically, the things you want to look at are make sure that all of your individual coils are getting tested at some point throughout the year and that you're getting those detailed numbers, right? So this is a big area where some companies will just have a line item that will say RF coils checked, right? And then there's a check mark or a pass. And so that could lead you to ask some questions like, well, when you check my RF coils, are you testing their performance? Or are you making sure that they are clean and that they don't have damage to the cables, damage to the pins? Are you, plugging them in and just making sure that there's a simple functional electrical check? All those things are important, but a mechanical inspection, an electrical inspection, a simple sort of plug-in, does the scanner recognize it type check, doesn't take the place of actually doing a scan with the coil and checking its imaging performance. So that's something that's important, and you want to make sure that that's listed out explicitly for each coil. The other part of that is if you're not getting numbers back, you'll want to ask. And some companies may say, yes, we can produce a supplemental report that will give you that information. Some companies will say that information is stored in your scanner, and here is how you can access it and print it out, or export it to a jump drive or something like that. So there's lots of ways to go about this. And if you ask, you may get different options from different manufacturers. The other thing you want to make sure is you want to make sure that the magnetic field homogeneity is actually being tested. Now, I've got this one marked with a couple of asterisks because we're going to talk about this in the next section when we go through vendor terminology. And what you find on your PM reports may not be something that says magnetic field homogeneity. There's a lot of different terms for this. So we're going to talk about what that looks like. Okay, I wanted to show a couple of samples of documents that were submitted for IAC accreditation for individual MRI facilities and show you some things, both some good and some not so good, that are happening out there with this kind of documentation. So this is a snapshot from a PM service report on an MRI system. And what I wanted to point out here was that where you see this blue box with the arrow indicating, this is a good thing. So what we're seeing here is a reference that says whatever this frequency measurement is, the range is supposed to be between 12.94 and 13.5 megahertz. And for this particular scanner, the measurement was 13.272. Right? We see that and we say that is exactly how this is supposed to be documented. There is no ambiguity here. It's very easy to say, hey, we have a range that this number is supposed to fall into. We can clearly see that it does. And what's interesting about this document, I haven't seen this in too many other places, but this one actually has 2 columns. So it appears that this was a report from a relatively new system, or maybe not. But you could see a factory column there and then a site column. So it appears that this particular device, which looks like an e-coil, was tested in the factory. This document was filled out and then shipped with the coil. And then when the coil was placed in service at the facility, it was tested again. So now you have comparison results to see how does this coil behave differently in the factory versus at the end user facility. That's a nice to have. That's not something you're going to see in every report, but I wanted to point it out because it's interesting and unusual. But the main thing here is to say for every one of these lines on a report like this, I would be able to look down the right-hand column and say, okay, there's the acceptable range, and there is the actual number, and yes, it falls right into that range, so it's a pass, no question, no argument. Clearly it was done. These are realistic numbers. These are not just made up. Okay, so this is an example of one of those things I was talking about where this is now a preventative maintenance report. The previous was an acceptance test report. So on this system, we have something marked on here that says signal to noise check, and it says the test purpose is for image quality, and then there's a check mark that says pass, and that's all the information that we have. So this is an example where when a document like this comes from the MRI manufacturer or the service company, we need to see more information because a signal to noise value is a number. So that's going to be 59 or 362 or something like that. And it really depends on what's the range, what's the expected range. And these can be written in a number of different ways. So on some manufacturers, they'll say, well, the signal to noise value, when it's measured using this particular calibration scan, must be within this range. And others will say, as long as the signal noise is greater than 50, you're fine. One of the things for my own curiosity when I see these types of things is if I see something where the signal to noise value is shown and it's something like 420, and then the spec says signal to noise must be greater than or equal to 35. And I say, well, that's great that it's so much better than the spec, but it makes me wonder whether the spec is appropriate. So something else to keep in mind when you're looking at these numbers, you don't want to see huge differences because at that point, something that has a normal signal noise ratio of over 400, by the time it drops below 35, there's going to be a lot more wrong with the system in order for something like that to happen. So you want something that's relatively close to the operating value so that if the number went outside of that range, it would actually serve as an early indicator that something was wrong before your system had major problems. So this is another example from a system preventative maintenance report. This was from their system performance section. So there's a lot of detailed information here, a lot of different things being looked at. So one of the things I thought was interesting here was that there is a uniformity number here quoted as 24%, and there's no specification or range given for this. So I can tell you from personal experience making a lot of measurements of uniformity on a lot of different MRI scanners, there are some situations where a 24% uniformity is fantastic for certain kinds of coils, certain kinds of situations. Other times, a 24% uniformity is terrible. And there's an additional wrinkle here that depending on how you're calculating uniformity, in some circumstances, a uniformity of 100% is considered perfect, and in other circumstances, a uniformity number of 0% is considered perfect. So from this sheet right here, I can't tell which situation we're looking at. I don't know if 24% is close to 0 on the good side or far from 100 on the good side. So a specification is needed here to be able to tell whether this is a good number or not. And again, that specification can be anything the manufacturer says is appropriate for that coil. So if you're measuring uniformity by the numbers, something like a head coil or a knee coil is going to have a very different tolerance from something like a shoulder coil or a spine coil. So that's why we rely on the manufacturers to tell us what that is. And then, of course, here we have the infamous magnet shim with an OK, right? So a magnet shim result should definitely have some numbers. And this one, especially, I'm sort of a pest about this because the shimming of the magnet, the homogeneity of the main magnetic field, is the single most important parameter that the performance of your whole system depends on. If your shim is out, nothing's going to work right. Everything you try is going to be compromised at best. So we really want to know when we're looking at magnet shim, not just is it passing, we want to know, is it just barely passing or is it like really, really good? So that's another reason why with magnet shim, especially, you want to see some numbers, you want to see a comparison range because you want to know exactly where you stand with it. That's a good measurement of your overall system health. I mentioned a moment ago that if you were to go through a sample of preventative maintenance reports in particular that have been submitted to the IAC, and I've gone through this exercise recently, there are a number of problems that show up fairly frequently. One of the most common is that if you look at the list of IAC required elements and then you go down to the preventative maintenance report, you will not see all of those tests being done or being listed. Very often you'll see the scenario where a test is listed, but it just says okay, or it says pass, or there's a check mark. You don't see any detail about the actual measurements. Or you see the measurements, but you don't see the reference range or the passing range. And then also quite common is to see a very extensive list of tests being done on the MRI scanner, but then there's no listing of tests and results for those individual RF coils. Now that I've scared you about how to fill out your paperwork, I'm going to give you some stuff to try to help you. You will have surely noticed, if you have spent any time looking at your preventative maintenance reports, as I went through the list of tests from the IAC standards, you may have seen some unfamiliar terms, or you may have seen some terms that don't show up in your manufacturer's reports. Part of the reason for that is that the IAC uses general terms for these tests. Individual manufacturers sometimes use their own terms, and there's a variety of reasons for that. Typically, the service engineers for a company will use their own trade name for a given test, or in many cases, they actually won't be talking about the name of the test itself. They'll be talking about the name of the tool that they use to do the test. So I've run into this quite a few times. So they say, well, we're measuring magnetic field homogeneity, and they'll refer to that parameter as a resonance probe. Say, I have to do a resonance probe on your scanner today. Well, what they're doing is they're measuring magnetic field homogeneity using a resonance probe. And so you have a term of art that's different between what the field service engineer is doing and what the accreditation program or what a medical physicist or somebody would refer to that overall concept as. When you look at bodies that are not manufacturer specific, so there are industry groups where the MRI manufacturers all put their heads together and come up with industry-wide standards for how they're going to report different performance and safety issues. Groups like NEMA or MITA within the United States, groups like IEC internationally, they have standardized names. So within an IEC document or within a NEMA document, they'll say, okay, we're all going to agree on a common definition of what signal-to-noise ratio is, and we're all going to call it that. That doesn't mean that every individual manufacturer will then use that same name when they develop tools for doing those assessments on their own equipment. When you look at the FDA and other government bodies, they will use general names that are not tied to any particular manufacturer. If you look at organizations like the ACR in their technical standards, they will use general names, maybe not the same ones that come from FDA or that come from NEMA or MITA. If you are involved at all with medical physicists, we tend to use general names. Some of these come from AAPM documents. Some of these come from collaborative documents that are developed by AAPM and ACR, like the technical standards. So any of these sources of names, whether they're general or whether they're vendor specific, may refer to the same things as the tests that are listed in the IAC standards. So the IAC standards are another group of what I would call general names. But again, there's nobody there's nobody that enforces a harmonization that says, okay, you know, IEC and ACR and AAPM and IAC, you guys all have to use the same names, right? Everybody's free to develop their own naming conventions depending on their own governance, their own needs, etc. So what IAC calls magnetic field homogeneity may show up with a number of different names when you're looking at other documents, book chapters, preventative maintenance reports. Very often you will see this referred to as B0 homogeneity or inhomogeneity. Oftentimes, company documentation will refer to this as magnet shim or magnet shimming. They may refer to a procedure called a shim check or a shim test. One manufacturer uses a procedure called an LV shim. So if you see something in a document that refers to an LV shim procedure, that's what this is. You may see terms like field mapping or shim plotting, right? So those are different methods of measuring. You may see something referring to something that has a spectral peak or an FWHM, a full width half max component. Those are methods that are used by some engineers and physicists to measure this, right? So, so this may require a little bit of translation between the document that you have and whoever provided it to walk it back to this general term, magnetic field homogeneity. Spatial resolution also is another one that shows up under a lot of different terms. So this is sometimes referred to as high contrast resolution. Some physicists and engineers will measure spatial resolution indirectly by measuring something called a modulation transfer function. A modulation transfer function is directly related to spatial resolution, but you measure it a different way, you calculate it a different way, but ultimately it's going to tell you the same kind of thing. One manufacturer uses something called a PIQT, which looks at spatial resolution. Then there are others. And then I listed these other three down here, although you're less likely to see them. Something like a point spread function, line spread function, edge spread function. These are related to a modulation transfer function, and there are sometimes software tools built into a scanner to calculate these values from a specific phantom scan. If those are on your scanner and if those are being reported in your PM documentation, those would be measurements that would reflect spatial resolution. And so I'm only pointing that out to say if your scanner or your physicist or whomever is doing this for you has a very technical way of getting at one of these transfer or spread functions, and they're not doing spatial resolution using a phantom that has bars or dots in it, that's okay. They're still assessing the spatial resolution of the scanner when they do that. So geometric accuracy shows up under a number of different names as well. Sometimes this is referred to as spatial accuracy, spatial linearity. Different manufacturers use terms like gradient sensitivity, gradient sizing. Those of you with sharp eyes will find that I have an error on this slide. So graphity, which is listed in the middle, is not a geometric accuracy tool. That is a manufacturer-specific name, and it belongs on one of my other slides coming up in a moment. So all of you guys can take out your pens and correct that on your monitor. So gradient sizing, image linearity, geometric distortion. Other than graphity, these are all names for the same thing. This is where graphity belongs. So gradient calibration is talking about all of the things that affect the gradients, and geometric accuracy is a big part of that. So gradient calibration has to be dialed in order for geometric accuracy to be good. But gradient calibration goes beyond just geometric accuracy. Gradient calibration is also going to affect things like slice position and slice thickness. Eddy current compensation is a big part of gradient calibration, and so is gradient shimming, right? So graphity is a manufacturer-specific term for an eddy current compensation. So gradient calibration is a big bucket, right? And the idea here is that we rely on the manufacturers to tell us, okay, what are the gradient calibrations that your system requires, and how often do you expect those to be done, and show us some documentation when you've done that there's some kind of a test that shows, okay, we ran this procedure, we got this number, it's supposed to be within this range, therefore we know that everything is running the way it should be. Right, so this one gets into a little bit of a gray area because you have to do a little bit of digging or a little bit of asking questions with your service engineer to find out what these procedures are. So RF calibration. RF calibration is basically the entire pathway that the RF signal takes from the transmitter into the patient, back into the coil, back into the receiver. So you'll see things like transmitter and receiver adjustment or gain. You'll see stuff like receive path calibration checks, coil tuning. All of this stuff is part of the RF calibration. When you get into vendors' tools, very often there will be tools on the system that will have automated tests. They'll have specifications built in that print out information after the test. There might be a password in front of that, so you may not be able to access those tools unless you are a service engineer or you have one with you. But that's something they should be doing as part of those PMs. Okay, artifact assessment is a big one. So there's a number of different ways to do an artifact assessment. So one of these is simply to run some scans, observe the images, look for anything that doesn't belong there. That's a very common one that's done as part of your daily QA. There are also numerical ways to assess artifacts where you can let the computer crunch on the images and say, well, is there anything in the signal that's not supposed to be there? So these might be referred to by names like image uniformity or image homogeneity. Those could be either visual or numerical assessments. You'll see things like stability checks or spike checks or spike noise or coherent noise. Those are all additional forms of artifact assessment that are done numerically by the scanner manufacturer using their tools. When it comes to reports, if possible, my request to all of you would be to label those categories using the names from the IAC standards. If you have a report that shows other names, whether they're manufacturer specific or report or names from like a NEMA or an AAPM, one option is to take a copy of that report and mark it up. So you write on there, where it says graphity, write on there gradient calibration. Right. Another way to do this is, like I mentioned earlier, if you take a copy of the IAC's Sample PM document and you sort of combine that with the manufacturer report, so you can go down the list and say, yes, gradient calibration is on page 3 of the report under the section, that says gradient sizing or what have you. That's another way to do it. Last couple of things, and I see we have some questions, so I want to make sure we get to those. If you look in the standards, you will see that the acceptance testing is required to be done at the installation of a system. And you say, well, we had our system put in several years ago. We're just now applying for accreditation. How does that work? So it's not a new installation at this time. Maybe it wasn't done at that time. Maybe it was. So my recommendation to you would be go back and look at any acceptance tests that were done. Did you get acceptance test documentation from the manufacturer? Did a medical physicist perform any acceptance testing? Another thing that's worth doing as you're beginning the accreditation process is to go through and do a full quote-unquote acceptance test. It's not a brand new system, but this will set a baseline for all these things that you're going to be monitoring closely that you may not have been monitoring in the past. And this is also a great opportunity to make sure that your system that's not brand new still meets all of the manufacturer specifications. So even if you've been doing preventative maintenance all that time, this is a chance to sort of reset and say, how are we doing right now today? Are we still meeting all those criteria? Another question with acceptance testing is what constitutes a major upgrade? And unfortunately, this is not something that's clearly defined. It's a case-by-case question. So if it were me and a facility said to me, we just had something done to our system, would you consider it a major upgrade? I would say, well, okay. Did you increase the number of RF channels available on your system? If so, that's probably a major upgrade because you have to replace a lot of hardware and software to do that. Did this upgrade end up replacing most or all of your bread and butter coils? If this is an upgrade that involves new head coil, spine coil, knee coil, shoulder coil, extremities, et cetera, et cetera, et cetera, that's probably a major upgrade, right? Bringing in one new neurovascular coil is probably not a major upgrade. Did somebody have to take apart the magnet and put in new gradient coils or put in a whole new body coil assembly? That's a major upgrade. Did the upgrade add any kind of exotic capabilities? So did you add parallel imaging that you didn't have before? Did you add multi-transmit capability? And then an easy rule of thumb is if this is an installation that takes more than an entire day, it's probably a major upgrade, unless that's purely software. Some software installs take a whole day. Don't ask me why. The other one that I didn't include here, but that is a hallmark, is if your system got a new serial number as a result of this upgrade, and I'm thinking of one company in particular that has done an upgrade like this, where the entire system gets a new serial number and it gets assigned a new manufacture date because they consider it basically a field remanufacture, that would be a major upgrade. So these things would trigger a need for another round of acceptance testing. You might have noticed in the list of tests earlier that we are interested in seeing QA of the monitors and printing devices. You might say, well, who cares, right? We put stickers on our films that say not for diagnostic use. Maybe I'm showing my mammography roots again. So just remember, if you are still printing film, and I see we have 96 people on the line, so statistically not one of you is doing that. But if you're printing film, just remember your film goes into the wild. And even if you didn't print it for someone to interpret diagnostically at your facility, once you send it out the door, someone else could well use it that way. So you're responsible for the quality that you produce. So you want to make sure that your filming devices are going to meet a diagnostic standard, even if you're not using them that way. Right? So that's something to consider when you're deciding whether you're going to have hard copy at all. When it comes to the console monitor, the argument I hear, from 99 out of 100 people is, why do you guys insist on sticking a photometer up to that monitor? Nobody reads off of it. Well, your technologists are sitting at that monitor all day, every day. And I can tell you, when I spend 4 to 6 hours at a monitor that winds up failing the test, I'm having a bad day by the end of that 4 to 6 hours. So, do a solid for the people that are doing the hard work on the front lines and make sure you get a good, crisp monitor that's bright enough that they can see what they're doing. And the other thing is just as someone finishes the words coming out their mouth, no one ever reads anything at this console. I'll see a cardiologist walk in, I'll see an emergency physician walk in, and they'll kind of put a hand on the MRI tech's shoulder and kind of do a friendly, hey, how's it going? How's the patient doing? As they're leaning in and peering at the screen. So whether or not you think your MRI console is being used for quote-unquote diagnostic purposes, physicians are looking at it, and they are making snap clinical judgments based on that so-called wet read. So we want to be careful about that. Quick summary, right? Keep those IAC standards close at hand. Print out those couple of pages with those lists of items. Use those as a checklist. Make sure everything in your documentation is done as required and that it's reported out, right? Including the values and including the limits and the ranges. Look for different names, right? And use some of those tips, or ask your vendors what those different procedures involve so that you can crosswalk those back to the general names. And really make use of that IAC sample document. We put that together as a tool so that you guys can go through and see what you're expected to have and very easily check it off. And maybe that makes a good substitute in some settings to say, well, if the reports or the forms we have don't have spaces for all the right information, we'll use this to provide it.
Great. At this time, we'll begin the Q&A session. From IAC MRI, I'd like to introduce Corey Mabry, IAC Director of Accreditation, who will assist with the Q&A session today. Corey, would you like to start us off?
Yes, thank you, Kelly. And again, Dr. Jordan, thank you for sharing this information with us today. First on the list, it doesn't necessarily pertain to preventative maintenance. What should we do if we're doing our operator QC and we notice an artifact on the QC images? What steps are to be taken there, Dr. Jordan?
So the question with an artifact that you see on QC is always whether or not it's going to be clinically significant. So, my conservative approach would be to check in with the medical director, right? Or check in with whoever from the medical staff is on duty that day and say, hey, we're running some QA this morning. We see something that looks a little off. Do you want to take a look at it? Do you want us to wait to scan patients before we, do you want us to get service down here? Do you want us to go ahead and start, but just be aware that you might see this? That's really a medical decision by the interpreting physician. One of the things that just as a basic technique would be to say, well, tear down your test and start over. So pull out the phantom, right, reseat the coil plugs, reposition the phantom, restart your session, run the scan again, because sometimes you get these little quirky things that just show up intermittently and then they're not there. Other times, you get something that's going to show up recurrent, and then you say, well, I need to call my service engineer. But as to whether you can go through and scan or whether you want to hold off, I would generally try to leave that decision to the physician who's ultimately going to be responsible for the study. Okay,
thanks, Dr. Jordan. That was a great answer. The next kind of dovetails in with what you were saying just a bit. Now, some facilities wonder, why should we keep a copy of, say, the PM, the acceptance tests, and our operator quality control test results? What benefit does that provide for our facility?
Well, keeping the acceptance test is critical because later on, if you see any kind of a change or a degradation in performance, you want to be able to point to that and say, well, hey, at installation it was this, and now it's 20% worse. So that becomes your leverage for trying to get that fixed. The routine, day-to-day QC results, those can also be helpful to see how any trends have unfolded. So, individually, day by day, you may be looking and saying, well, my values just move, a little bit, or they don't, but they stay within these ranges. But if you look at the longer trend over a period of months or even years, sometimes you can identify some trends that help you to understand how the system behaves. So a big one that we see with superconductors is, do we see a drift in the center frequency that tells us that there's a drift in the overall magnetic field over time? Some systems do, some don't. That's not to say that everybody is going to go digging in that data, but you can't go digging in that data if you don't have it.
Okay, thank you very much. Next question, and Dr. Jordan, I think you may have already addressed this, but say a client gets that preventative maintenance record and they notice that they don't have the numbers that are measured as well as the reference values. What was the guidance that you offered earlier in the webinar about that?
The first thing I would do is I would ask if there's any kind of an extended report that they can send, and some companies do. So some companies have a document which is normally kept internally, but they can transmit it directly to a customer, which will have more of those details in it. And so if you ask for it, many of them will be happy to give it to you. The other opportunity is to say, hey, I see that you did these tests, you marked them pass. We would like to capture the details of those things. And you may say, well, is there a place we can go in on the scanner and access that information? And sometimes there is. Sometimes just a log file, or a QA browser or something like that, where you can actually go in and see that information. Even if it's not something you're normally used to doing, they may be able to walk you through it. So those would be two options to get that information. The other option, which I would personally recommend, but which may be controversial, is you may at some point find it necessary to engage a third party who is not the equipment manufacturer, who is qualified to do some of these measurements, who will report it for you in a format that is more acceptable. Okay, good. So next question, this perhaps will be the last one. Unfortunately, we're running out of time. This facility does not run or operate their MRI scanner every day. Do they still need to perform the operator QC on the days when they're not there, or what's your thoughts on that? So my understanding is that your daily QA is needed on days of patient use. That will probably be sufficient for most situations. There may be things that you want to monitor every day that there are staff on site, even if you're not scanning patients, right? So one example of that would be if you have to monitor and report your cryogen levels every so often. On the day that comes up, I would make sure to grab that number and, call it in or upload it or whatever you have to do, even if that's not a day you're scanning patients, because you don't want to get off track with that kind of thing that relates to the ongoing health of the system, whether you're using it or not. Okay, great. Thanks for that information. And at this point, I'm going to turn the presentation back over to Kelly. However, if you notice that you asked a question that wasn't answered, IAC staff will follow up with you within the next several days about that question. Kelly?
Okay. Thanks again, everyone, and a very special thank you to our guest presenter, Dr. David Jordan. Again, we invite you to contact IAC with any questions that were not answered during the Q&A session. To receive continuing education credit for attending this webinar, please complete the survey. The survey will appear on your screen automatically at the conclusion of this live session and also be available from the IAC Pro Libraries website for 3 business days. In the upper left, you'll click on My Webinars, look for the title of this session, Understanding MRI Equipment Quality Control. Beneath this title, you will see the link Take Evaluation. Click this link to complete the survey. Your certificate can then be accessed and printed from the very next screen and anytime thereafter through a new link on the My Webinars page called View Certificate. If you have any questions about the survey, please contact us at webinars@intersocietal.org. Once again, we thank you all for joining us today and appreciate your participation.